In objective 6, we're looking at multiplying two polynomials that are both not monomial. Okay, so what we do here is we multiply, say, the first term in the first polynomial by both of the terms in the second polynomial. So the first term in the first polynomial gets multiplied by both of the terms in the second polynomial, and continue like that. Multiply the second term in the first by both the terms in the second, which is what we see being done right here. The second term in the first by both terms in the second. So our net result is first term in the first times each of the terms in the second is going to lead us with A times C plus A times D. Okay, good. Then we do plus the second term in the first, which is B times C, and B times D. Okay. So each term from the first polynomial will get multiplied by each term in the second. So let's take a look at the next example. X, we're going to multiply by x and by 6. We're using the distributive property twice here. X times x is x squared. X times 6 is 6x. Then plus 4 times x, making sure this 4 also gets distributed to the next polynomial. Plus 4 times 6 is 24. Then we combine our like terms for a final answer of x squared plus 4x plus 6x is 10x plus 24. Right, and we finished the double distribute, and we've combined our like terms, so we have our final answer. Try it again in the next one. When I multiply two polynomials together, I'm going to distribute both parts of the first polynomial into the second. So 2x times 3x is 6x squared. 2x times 7 is plus 14x. And negative 5 times 3x is negative 15x. Negative 5 times 7 is negative 35. Like terms need to be combined, so my final answer is going to be 6x squared. 14 minus 15 will be minus x minus 35. Let's look at a few more examples. Alright, we'll start off our distributed process again. 5x times 5x is 25x squared. Then we've got 5x times negative 3, negative 15x. Then we've got negative 3 times 5x for negative 15x. And negative 3 times negative 3 for positive 9. So the final answer here is 25x squared minus 30x plus 9. When I combine those two like terms up, I get the negative 30x I just wrote in the middle. Okay, next. Okay, in this one, start with 4x times 4x is 16x squared. Plus 4 times 7 is 28x. Then I've got negative 7 times 4 is minus 28x. And negative 7 times positive 7 is minus 49. Negative 28 and positive 28 add to 0. So I have 16x squared minus 49 in this one. Okay, let's look at the next one. 4x squared times 4w squared times 3w is going to be 12w cubed minus 20w squared from 4 times 5. Then I'm going to have plus 2 times 3w is 6w, and 2 times 5, so minus 10. There aren't any like terms in this one, so it's already done. I only have to combine if I do have like terms, and this one doesn't. Okay, and in our last one here, we're going to do the distribute still, but since there are 3 terms, we'll just make sure that the 2x gets multiplied by all 3 things, and likewise the 5 is going to get multiplied by all 3 things. Okay, so I start with 2x to the third, x times x is x to the third, minus 6x squared plus 8x, then coming back with a minus 5x squared plus 15x and a minus 20. Right? Let's make sure we write this in descending order as we combine like terms. So we're going to start with 2x cubed minus 11x squared, negative 6 and 5 is negative 11. 8x plus 15x will be plus 23x. And then the constant minus 20, it's just at the end there. Alright, a couple more examples. So the next one is also going to be two terms distributed into 3. So we'll make sure we multiply 2x squared into all 3 terms, and likewise negative 3 into all 3 terms. So we're going to start with 8x to the 4th plus 6x cubed minus 10x squared. Okay, right? So that was 2 times 4 is 8, x to the 4th, 2 times 3 is 6, x to the 3rd, and 2 times negative 5 is negative 10, x squared. Now for the negative 3, that'll be negative 12, x squared, minus 9, x, plus 15. Looks like we've got just one like term to combine, the x squared term, so let's go ahead and write the 8x to the 4th plus 6x cubed minus 22 x squared minus 9x plus 15. Alright, and our last one here, we've got 3 terms in the first parenthesis that are going to get distributed into all 3 terms in the second parenthesis. So starting with 3p squared times p squared is 3p to the 4th. 3p squared times 3p is plus 9p to the 3rd. And 3p squared times negative 4 is negative 12p squared. I'm using a different color just to show the next piece. The next piece is negative p times all 3 parts of the second parenthesis. So negative p times p squared be minus p to the 3rd. Negative p times 3p be minus 3p squared. And negative p times negative 4 will be plus 4p. And yet one more color for multiplying the 2 into all 3 terms. 2 times p squared is plus 2p squared. 2 times 3p is plus 6p. 2 times negative 4 is minus 8. Add these all up. I kind of wrote them in the vertical format here. So I'm going to add up all the like terms. You can see them arranged vertically. They just wouldn't all fit horizontally as I had been doing, so I chose to use this method instead. So my answer is going to be 3p to the 4th plus 8p to the 3rd. If I add up my p to the 3rds, let's see, 12 minus 1, negative 12 minus 1, so that'll be negative 13 p squared, and plus 10p minus 8 for my final answer. So distributing can be done no matter how many terms you have, as long as you just multiply the first term by everything in the second, and so on until you finish both parentheses. Okay. On the next page, looking at squaring a binomial, when I write x plus y squared, we mean x plus y times x plus y. Squaring anything means to multiply it by itself. Okay. So, I'm not sure why I have this twice, but so this is going to be x plus y times x plus y. And if it's minus, no big deal, it's just x minus y times x minus y. Okay, and then to simplify any of these, we're going to use the distributed process to multiply it all the way out. So let's look at a couple of examples. Okay, so in the first example, we are going to look at x plus 5 squared. So that's x plus 5 times x plus 5. So when we multiply this out, x times x is x squared. x times 5 is 5x plus 5x plus 25. So to combine my like terms, I've got x squared plus 10x plus 25. Okay? Same thing, if I've got negative, doesn't matter. So I've got x minus 3 times x minus 3. Distribute it all the way out, so x times x is x squared minus 3x minus 3x plus 9. So x squared minus 6x plus 9. Okay. So if I need to take 2x plus 5 squared, I need to first write it as 2k plus 5 times 2k plus 5. 2k times 2k is 4k squared. 2k times 5 is 10k. 5 times 2k is 10k. And 5 times 5 is 25. For an answer of 4k squared plus 10 and 10 is 20k plus 25. And our last one here, if I want to square 3x minus 6, I better write that twice because I need to do the distributive property. So 3x times 3x is 9x squared. 3x times 6 is minus 18x. Negative 6 times 3x is negative 18x. And negative 6 times negative 6 is plus 36. So I've got 9x squared. 18 plus 18 is 36, so that's going to be minus 36x plus 36. Okay. Now let's compare the properties between x plus y squared and x plus y. Sorry, xy squared and x plus y squared. If I have x, y squared, that's the same thing as x squared and y squared. If I have x plus y squared, that's the same thing as x plus y times x plus y, which is x squared plus xy plus xy plus y squared, or x squared plus 2xy plus y squared. Note, this is not the same as x squared plus y squared. If it's a product, we have a property that says I can square both pieces of that product. Remembering that xy squared means xy times xy is x squared y squared. This is not the same thing when I look at x plus y squared. It's not the same thing as x squared plus y squared. It's a different answer. I need to make sure I multiply it out twice to get the full and complete answer. Okay. Now when I have the sum and difference of two terms, okay, x times x is x squared. X times negative 5 is negative 5x. 5 times x is positive 5x. And negative 5 times positive 5 is negative 25. When I have the sum and difference of two terms, notice that the middle two terms are opposites here, so when I add them up, they add to 0. And I end up with x squared minus 25. Okay, that happens because I have two opposites. One is x plus 5 and one's x minus 5. It's going to happen in this one also. A plus b and a minus b. A times a is a squared. A times b is negative ab. B times a is positive ab. B times negative b is negative b squared. Negative ab plus ab add to 0, so I have a squared minus b squared. When we have the sum of two terms and the difference of two terms, we call these conjugates.